Good morning, everyone. I'm Alina, Program Manager for TensorFlow. Thank you. Welcome to the 2019 TensorFlow Developer Summit. This is our third annual and largest developer summit to date, and I'm so happy to have all of you here, both right here in the room and on the live stream. Welcome. So I'm just curious, by a show of hands, who traveled a little bit further maybe to get here? Europe? Asia? Africa? As far as Australia? Woo! Awesome. Welcome to all of you. We have a lot of great talks ahead, some exciting announcements and cool demos, so let's get going. We are living in a formative moment of history right now, where machine learning is experiencing an unprecedented revolution that we fundamentally think about and interact with computer systems has inherently changed due to the breakthroughs in the field of AI. And this is due to three major factors. First, we have lots more compute, specially designed ML accelerators like these TPUs let you train models faster than ever before. Secondly, we have breakthroughs in the field of machine learning. There are novel algorithms created every month, like BERT, and an innovative approach to natural language processing, which lets anyone around the world train their own state-of-the-art question answering system. And finally, we have lots and lots of data. We're seeing new waves of data sets come from all kinds of disciplines. For example, the new Open Images Extended dataset. This is a collection of over 478,000 images that volunteers have added with the pursuit of inclusivity and diversity. So all three of these are basically changing how we solve challenging real-world problems. And it's really cool to see that TensorFlow is the platform that's
and the background. And further, I can even grab other objects, such as this TF Light sticker. It looks very similar, right? It's the same color. So let's see, what was the class I used? Yellow, okay. Sorry. So now, even though it's a similar color, it can still discern the TensorFlow Light logo from the tangerine. Oh, sorry, tangerine, there we go. So you can imagine, in a manufacturing context, your operators with no knowledge of machine learning or training in machine learning can adapt your system easily and quickly using this exact technique. So that's about it for the demo. But before I go, I should grab the clicker, and also I should say, we're also giving away some Edge TPU accelerators. For those of you here today, we'll have one available for you as well. And for those of you on the live stream, you can purchase one at coral.withgoogle.com. Okay. So we've also got some links for you up here. Please take a look at the TensorFlow Lite and our new hardware. And thank you very much.
Hi everyone, my name is Gal Oshri, and I'm here to talk to you about TensorBoard and what's new in TensorFlow's visualization toolkit. So how many of you have used TensorBoard before? Awesome. So as you know, TensorBoard helps you visualize a lot of the data that comes out of TensorFlow. It has a wide variety of features, but today we're going to talk about a couple of new additions. So we're actually going to switch over to a demo.
Livestream, we're doing a contributor luncheon tomorrow where there'll be a little panel discussion about contributing to TensorFlow, and many of the core team and the SIG leaders will be there to talk to you. So, finally, let's move on and talk about TensorFlow World. I'm so excited about this. It's our vision to bring together the amazing people who are part of our community and give us space for everyone to connect with each other. You know, there's so much we can all learn from how we're all working with TensorFlow. So working with O'Reilly Media, we're going to have this event at the end of October this year here in Santa Clara. It'll be 4 days that really celebrate the TensorFlow ecosystem. We'll have content from talks to tutorials. There'll be an expo and a place for vendors to present. So we understand that as TensorFlow gets out into the real world, there's a large ecosystem beyond folks in this room. And we're really excited that that means that we can bring everyone together. You know, the main point of doing something like this is to connect all the amazing users and everyone with experience to share. As you heard, the call for proposals is now open. So if you have anything to share with your work, your product, your company, head to TensorFlow World, put in a proposal. You've got about 4 or 5 weeks while the call for proposals is open, and then we'll be selecting talks a few weeks after that. I really hope that you will lend your voice to this event, and I'm so excited to see you all in October. Once again, thank you. We really appreciate how much that you are part of our community. Honestly, in my job, the best thing every day is when I get to talk to folks who are using or developing TensorFlow, and I know that's the same for everyone in the team. It really is so exciting to work with everybody here. This is the way you can meet me. Please do, if you have any issue or any desire to contribute or get involved with the community, reach out. We're really happy to talk to you. So thank you very much for your attention.
Airbnb is an online marketplace. We have over 5 million different homes in 81,000 cities, which equates to hundreds of millions of photos, making it possibly the largest collection of images of homes in the world today. When a guest decides to select a home, one of the biggest influences in their decision is a diverse set of images. But a lot of times hosts will take a lot of pictures of a single room and forget to take pictures of the other rooms.
They also have the option to add captions, but a lot of cases they're totally off.
We were faced with a challenge of identifying what's actually in these pictures and present them properly on the site. That's one area where machine learning excels. The real challenge was one of scale. We had upwards of 500 million images to get through. It was going to take months to really go through all of these.
Using TensorFlow, we were able to speed up the process and deliver a reasonable model within days. BigHead is Airbnb's machine learning platform. We had the idea of making it very agnostic to different ML frameworks, and so we leveraged TensorFlow to train the model, and then BigHead helps with the model lifecycle, the feature management, and then TensorFlow serving to help serve the model results.
Before you think about which tool to use, you first think about which model to use, right? And we did research on this. We find that ResNet 50 was one of the state-of-the-art performing models. We used that as the basic architecture.
We used TensorFlow's Keras APIs and serving and some of the distributed GPU computations. This ultimately led to a pipeline that we could deploy to go through hundreds of millions of images very quickly.
So the end goal is basically using these classifications of images to make sure that their first initial set of photos that they see aren't just a picture of the garage and bathroom, but it could be of the living room that's gorgeous, in the bedroom, in the swimming pool. Future applications could be to detect different objects in homes, and if users decide to search on the website for specific amenity types, we can actually bubble that up to the surface.
If you like how Airbnb operates today, the reason was because of machine learning, because machine learning is almost everywhere in the company. Search ranking, pricing, predicting booking.
We're passing into the hundreds of models, so it's something I expect to keep growing.
And with a lot of these new frameworks coming out, we can make better experiences for our guests and better business decisions as well.
All right. Welcome back, everyone. That's a great case study. I know that some of our friends at Airbnb are in the audience. Let's give them another round.
It has these two new symbols we just saw, up.load and up.CarsLayer, and they are usable in TensorFlow 2, both in eager and graph mode. To let you preview this functionality, we have published some modules in this format, and the next steps for us is to backport existing models. Okay, a bit more practical now. Google AI and DeepMind teams have been sharing their research with you on tfhub.dev. This was already launched last year, and there are some new modules, and we're going to have a look at some of those. One of the most popular was the Universal Sentence Encoder. This was a module that encoded short sentences into a high-dimensional vector that could be used for many natural language tasks. Recently, the team has added a cross-lingual version of this. So sentences with similar meaning, independent of the language, they'll end up in points close together. What's exciting about this is that now you can learn a classifier using English data, and then you could run it on other languages. We have also added image augmentation modules. The policies to augment images were trained by reinforcement learning on tasks such as ImageNet, and they have been shown to transfer to new tasks. An interesting thing is that you could grab this module and you could grab one of the image representation modules, and you could string them together. In this case, the image augmentation module would reduce the amount of data by data augmentation and the image feature vector by transfer learning. And there are many more. We have BERT module for text tasks. We have object detection modules, BigGAN modules for controlled image generation, di3D kinetics for video action recognition, and more. Some of these models' architectures were specially designed for low resources. Additionally, we have been working making modules more integrated with other pieces of TensorFlow ecosystem. We have a command line utility to convert a hub module into a TF.js model. Hub models can be used together with AutoNet, which is a library for AutoML. And they can also be used inside TF Transform. So if you want to try it, you can go to tfhub.dev and you can search for modules. Most of them include a link where you can see them in action. Thank you.
Extreme weather is changing. There's more extreme rainfall, heavy flooding, forest fires. There isn't really a signature done. Being able to predict these extreme events more accurately is kind of the big challenge that we're facing right now. There's 100 terabytes of climate data every day from satellites, from observations, from models. So climate data is a big data problem. We need things that are fast, that can sift through all of that data rapidly and accurately. And deep learning is almost perfectly poised for problems in climate science.
A lot of NERSC users are using TensorFlow. It's one of the more popular frameworks. We use TensorFlow to iterate quickly over different models, different layer parameters. For this particular climate project, to create the deep learning model, we started from segmentation models which have proven to be successful, for example, our satellite imagery segmentation tasks. And then we used TensorFlow to enhance the models until we found like a set of models which perform well enough for this specific task. But for the volume of the data, complexity of the data, the network required 14 teraflops. So if you want to do this on your workstation, it would take like months to train.
To really tackle these problems requires the largest computational resources that are available on the planet. So systems like the Summit supercomputer. 2 tennis courts in total size. I mean, this thing is state-of-the-art. It's 1,000,000 times faster than your common laptop. 3.3 exaflops. Just imagine what you do at your workstation, but now imagine having 27,000 times that power. We can do that now.
We were surprised how good it actually scales. 1,000 nodes and 2,000 nodes, 5,000 nodes.
This was the first time anybody's ever run an AI application at this scale. Instead of having the climate scientists figure out how to write high-tune code, they could express things in a very natural way in Python in TensorFlow and get all the high-performance code that most HPC people are used to within TensorFlow.
We're now entering the space where AI can actually contribute to the predictions of these extreme weather events.
When you combine traditional HPC with AI, you can tackle things we never thought that we could tackle. Fusion reactor research, understanding diseases like Alzheimer's, cancer, right? That's incredible.
We've shown that with a high productivity framework such as TensorFlow, you can get to massive scale and you can get awesome performance and accomplish your goals.
Genetics, neuroscience, cosmology, high energy physics. That's immensely exciting for me.
Okay, hello everyone. I'm Josh Dillon, and I'm a lead on the TensorFlow probability team. And today, I'm going to talk to you about probability stuff and how it relates to TensorFlow stuff. So let's find out what that means. Okay, so these days, machine learning often means specifying deep model
Thank you, Elena. All right, this is the end of day one. We hope you had a great time. A big thank you to our speakers, our staff, our crew, and to the audience here in Sunnyvale and all around the world. And with that, let's take the live stream out with a look at some highlights.